Okay, girls. Today we're going to continue in Chapter 3. We're going to do Section 2. You can call this section Families of Functions. Now, let me tell you first about this word function, okay? I can remember in high school and starting, well, a lot of college time, not liking that word, thinking, I don't really get this word. I mean, my teachers used it all the time, and I guess it never caused me like to fail a test or anything, but I never felt like I knew what a function was. I got this idea it must have been pretty important because it was used over and over and over again, okay? So let me tell you what I have learned even since I've been out of school and actually been teaching. The concept of a function is really very basic, okay?
Please pardon the interruption. At this time, please release all mass participants, choir members, Mimi Sardula, and Kelsey Abear to the gym. Thank you.
If you take a group of ordered pairs, and I'm going to make this a very small group, and if you have to, when you look at the x coordinates in each ordered pair, and you can see that each x coordinate has only one y coordinate as its partner, then this is a function. Yeah, that's all it takes. You can have as little as one ordered pair in the function, which isn't very practical because you don't get very far dealing with one ordered pair as a function, but it's legal, it's valid. Or you can have infinitely many ordered pairs in your function. But the key is not how many, but that every x has only one y for its partner. So in this problem, 3 is the partner, 1 is the partner for 3, and that's the only partner 3 has. 2's partner is 5, and -1's partner is 4. This is an example of a function, okay? And as long as that's what you have, a group of ordered pairs with that requirement being fulfilled, then you have a function. So we're going to be talking about lots of different functions in this section, actually in this whole chapter. Now, let me show you what's not a function. If I take, let's make another set of ordered pairs. And how about this time I go 3, 1, but then I put 3, 7. And I also put 6, 5, and 0, 2. Can I say that every x coordinate in this group of ordered pairs has only one y partner? No. 3 has a partner of 1, and then it comes back again and has a partner of 7. This is not a function. This is not an example of a function. Now, so this first example is a function. This second example cannot be called a function. We can, however, just in case you hear it again, you'll know what people are talking about. We can call the second example a relation. It falls short on the function requirements, but at least we have the ability to call it a relation. That's just any set of ordered pairs. Any set of ordered pairs. Now, do you remember in Algebra 2, it would have been, where you were given a drawing, a graph, and asked to discover or to decide if it was a function or not? I'm going to draw a picture that I think you'll recognize. Which shape is that? Say it. Parabola shape, right? That is a parabola shape. Suppose I want to know if that's a function. Well, I'm not giving you the ordered pairs, right? But you were taught a method to determine if a graph was a function. Does anybody remember what that method was? It was a certain test. It was called a test. Did somebody say something? Abby?
I can't remember.
Okay, how about a vertical line test? Does that ring a bell at all?
Yeah.
Yeah, that's where you imagine, or you're welcome to do the actual drawing of the vertical lines, but you can do it just in your mind's eye. But you're picturing vertical lines going anywhere you want to put them on this graph, and if every vertical line touches the graph only one time, then that means that is a function. So I think you can imagine, even though I've only put 4 vertical lines on the picture, that no matter how many I put up there, how many times is a vertical line going to touch this graph? Once. So this is an example of a function also. Okay? Yes,
Wait,
go ahead,
can you
Nicole.
repeat that with the lines?
Okay, if any vertical line that you can draw will only touch the graph one time, then the graph is a function. Okay? Now I do want you to be careful with that. Let me just point this out to you, okay? Watch this crazy drawing. Okay? Now you've never seen that shape before. But it is, I can still ask the question, do you think this shape is the shape of a function?
No.
Why not?
Because if you put a line through that little squiggly thing in the middle, it would touch the line twice.
Okay, so Hannah's saying if I put a line maybe somewhere around like that, how many times do I touch the graph?
3.
3. Certainly more than one time. And as soon as you can do that, what does that say?
Relation.
Yeah, only a relation, not a function. Now let me warn you, the reason I chose this particular shape is because sometimes what students do is this. They put a line here and they say, oh look, it only touches once. Look, once, once, once. Well, that's true. I could draw many lines on this graph and they can only touch the graph once. Those are not what's important. What's important is, can you find a place to put a line where it touches more than once? If you can just find one place where that happens, then you don't have a function. Okay? All right. So, don't panic about functions, all right? They're just a bunch of ordered pairs. That's all they are. And you know what ordered pairs are. I know you have no fear of an ordered pair. All right. Now, this section I said was called families of functions.